If I try to hook up a 6-volt bulb to a 9-volt battery, the result will be the destruction of the bulb. I need to find a way to drop the voltage of the battery to 6 volts so that the bulb can run. One solution would be to add a resistor in series with the bulb to cut down the voltage. If I press the button now, the bulb doesn't blow up, but it's definitely not at full brightness. So how do I calculate the value of this resistor? The first step is to measure the resistance of the lamp. A lamp is actually a little bit different than a resistor. A real lamp will change its resistance with heat. We're going to assume that this is an ideal lamp that's resistance is the same at every temperature. So I'm going to go to the meters tab and I'll bring out an ohm meter to measure the resistance of the lamp. And I'll increase its size a little bit by pressing plus on the numeric keypad. If you want to measure the resistance of a component, it's best that one part of the component is not in the circuit. Otherwise, you may end up measuring the circuit as well. So I'm going to delete this wire for the time being, and I'm going to connect to the lamp to measure its resistance. Okay, so the resistance of the lamp is 9 ohms. We can see that the circuit we want to design is a series circuit with 2 resistors, the voltage dropping resistor with an unknown resistance, and the lamp with a resistance of 9 ohms. Ohm's law will allow you to calculate voltage, current, or resistance, as long as you know the other 2 quantities. When solving a circuit problem, always look for the part of the circuit where you know 2 of the 3 quantities. We know that the voltage across the lamp must be 6 volts. This, along with the resistance of the lamp, gives us 2 quantities. The current through the lamp is given by I2 equals V2 divided by R2. We have 6 volts across a 9 ohm lamp, which gives us a current of 0.67 amps. A series circuit has only one path for current to flow. I total is equal to I1 is equal to I2. If I2 equals 0.67 amps, then I1 is equal to 0.67 amps. We can calculate the voltage across R1 using the equation for voltages in a series circuit. The total voltage equals the sum of the voltages across the loads. We can arrange this formula to get V1 equals V total minus V2, or V1 equals 9 volts minus 6 volts. That gives us 3 volts on V1. We can look at the calculation of V1 from a circuit point of view. If the battery puts out 9 volts and 6 volts are burned up across the lamp, that leaves 3 volts to be burned up by the resistor. Now that we know 2 things about R1, voltage and current, we can calculate the third, resistance. The resistance of R1 equals V1 divided by I1, or 3 volts divided by 0.67 amps. That gives us a resistance of 4.48 ohms. We need a resistor of at least 4.48 ohms to prevent the bulb from burning out. We'll test our calculations in the next video.